Our first presentation is going to be by Dr. Kaya, who's going to talk. Ohio University has a series of regional campuses, and one of them is in Lancaster. We have a special partnership with the Fairfield County Workforce Center. The county commissioners have invested in a facility there that we co-share with Hocking College. So Hocking College has several programs up there, and we are offering some offerings as well. The Workforce Center is undergoing some renovations, and one of the things that they're going to be doing is putting in some lab space for a semiconductor training program. So the same curriculum that Chip and Zayden State are offering, we're adopting the same thing. We're not trying to compete. The region is large enough that we're probably not going to be pulling students from Zanesville to Lancaster or from Belmont County. So we're trying to cover the area though, and make sure that students from the Fairfield County and Franklin County area and others can get access to. So they'll be pulling that in. After Savas is done, we've got Trevor Warfield, Jessica Smith from Hocking College. Trevor joined Hocking College from Lancaster, from our Lancaster branch just recently, so he can talk very, very well about, no hard feelings, Trevor. He can talk he'll talk more closely about what Hocking College is doing there, and could probably talk a little bit about what OU is or used to be doing there up there. Jessica's talk about K-12 outreach and workforce training there as well. After they're done, then we'll give you a chance to get up on Friday afternoon or move around a little bit. We've got stations set up around the building. So Dr. Ali, who talked earlier this week about packaging and thermal management and integration of the chip with the package and things of that nature, has a demonstration set up in his lab in the building, and so you can go there and look at the chip under operational conditions. I think it's an Arduino he's got set up. Actually, we'll be measuring the heat capacity that's coming off of as you ramp up the cycle time on the chip, and you'll see the heat coming off with the infrared camera and things of that nature. We've got Dr. Deering from the Engineering and Technology program, who's been working with a couple of other colleagues. He's got the robotics group, and so we've got the robotics lab here on the first floor, and then we've got the AR/VR simulation. I can't remember if it's the third floor or the fourth floor upstairs. So we've got tour guides to help you get around the building, so we'll help you get there. And then lastly, Juan Carlos has the Marietta lab set up outside, which is a very unique opportunity, unique asset. This is an asset that Marietta College supports, and you guys are available to travel around the region. You're mobile, so that's really nice. I'll just also put a plug here. We had reached out to Shawnee State that has a similar lab. Theirs is more on manufacturing technologies, but they're doing camps this week, and so theirs is already being put in service. So we're trying to identify these assets, promote them more, get them used. Of course, they're expensive to buy and to maintain, and have folks drive around, and the technicians and the operators to explain and talk to kids and things of that nature. But they're equally expensive when they're sitting in a parking lot and not being used, and it's kind of an underutilized resource. So we want to make sure that people are aware of this, these kinds of opportunities, and so we want to lift those up and try to get them used more regularly. So, and then lastly, again, when you get the evaluation, please fill out the evaluation. We really want to hear from you. So with that, I don't know if I'm going to get a chance to talk to you again before. So I want to thank all of you who have been with us this week, especially those of you who have been with us for a long period of time this week. This has been a bit of a marathon, but hopefully you find this beneficial, useful. This is certainly different than sitting in front in your office or your lab staring at a laptop or a computer. So this is really what it's about, getting this experience of learning. This is really important to us. So hopefully you enjoyed it. If not, you'll let us know on your evaluation. So with that, I think I'll turn things over to Dr. Kaya. Are you just about ready?
Yes. I am.
Finally. It's a just-in-time presentation, I believe.
Indeed. So. Well, thank you, Scott. Indeed, so yesterday evening we worked on the clean room air and we were very astonished with the results. We wanted to take the readings again to be sure because it was reading so good, at least against my expectations, so that I couldn't necessarily put this presentation as, so that I had to kind of do some morning work. But what I wanted to present here, without taking too much credit because I am part of a team who's behind this idea of Semiconductor Training Lab. The idea, especially with the funding that has been that we at least found to put it together. The idea is that semiconductor training, especially Intel's expectation, demands that we actually let, even at the technician level, let these folks into an environment where they will recognize the equipment, understand the basic principles of instruments, especially the vacuum equipment, because whether we underline or not, most of the wafer processing is taken under vacuum conditions. Or it's in a clean environment when it's not in the vacuum, but actually many of the processing steps may require vacuum equipment or very specialized equipment. And these technicians obviously will be maintaining those instruments. But I think it is detrimental for training of that you see some basic process steps, understanding needs and implications of one process on another, as well as actually dealing with this equipment at a fundamental level. Because the technicians are actually basically babysitting this equipment at a very high level, making sure this equipment are taken care before they break down, because industry cannot afford downtime, prolonged downtime, so they will monitor this equipment and understand that it is deteriorating and they will have to take care before things go really bad. Obviously, I know many of you may have seen this slide, but just for those who are new today, these are the partner institutions in ASCENT. I've taken this slide from Todd, who's put together, and Scott, slides like this. So this semiconductor training lab, hopefully, for educational purposes, not necessarily in the main campus, as I will explain in Lancaster, is going to be available for all partners who may want to bring students in if they don't have the facilities. So the team is all listed here. This includes both technical college, four-year colleges, and career development centers. Obviously, our geography is on the southeast corner of the state, but actually, if you look at some of the teams Intel have put together in the CERT program, we are one of the larger geographical areas. Of course, our geographical area doesn't have a big metropolitan. We are just edge of Columbus, so we have other challenges. Our the travel and the social background in this region is that we're talking about a lot of underserved communities who may not even afford the travel sort of kind of implications of cost and time in some cases. But remember, the overall objective ASCENT is to trickle all the, first of all, locate, reach out, locate, train, and hopefully forward that workforce, being prepared for Intel's internal training at least, into the Intel side. And Intel is obligated by CHIPS Act to really reach out to underserved communities, making sure it's a diverse and equitable workforce. So I think we therefore are in their radar. That's how I feel. I don't know if you correctly, Scott, if I'm wrong.
And I would just add,
yes,
I was saying earlier that we're also backfilling and making sure that we have this workforce available for the entire region. It's not just Intel.
Absolutely,
right?
absolutely.
This is really an advanced manufacturing thrust, and Intel gets that. They understand not all of our, in fact, very few of the graduates are going to actually go to Intel, but they're going to need people for their suppliers, for their secondary suppliers, to backfill the jobs that were taken from people in the region that went to Intel. So absolutely, it really is a whole workforce development program.
Absolutely. In fact, I would be very surprised if in a number of years, maybe in the next few years, ASCENT is approached by other companies and saying that, oh, we like what you're doing for Intel, can you do something like this for us too.
And
Yes.
it's a chicken and egg thing, right? So the suppliers are going to come and go, we want a site down here, but there's no workforce. So if you have the educational assets in place and you can demonstrate that you can have that workforce ready, then they're going to come here.
Well,
And we can do it.
yeah, because the workforce is, the first question that any kind of potential employer is going to ask when they look at a site is, where is my workforce going to come from?
Right.
And the answer cannot be, we'll get it for you in 4 years. It has to be, it's here.
And that's how we operate.
Yes.
And we need to lay out actual facilities show. They are not going to be convinced with promises.
Right, exactly.
So do I hear you correctly, that you are saying that we are privileged to be located in the southeastern Ohio?
It cuts both ways. It depends on how you spin it. I think we all know academics, when we apply, we always say, oh, we are in the southeast corner, we are underserved, give us more resources. But at the same time, you flip the argument sometimes that we can supply that human source. So this is obviously familiar. Again, remember, this is not just for 4-year master's PhD programs. This is a vertically integrated program. I like to argue our K through educators here. We are not here to talk, our research interests. While we have them, and we are talking with Intel about developing those research ideas as well. But this particular group and this activity and these workshops like this, we're open so that we can at least tell you what kind of skills are needed. You could reflect that in the classroom or in your curriculum development. We can help you put together things for the actual high school activities. We can come do demos in the high schools. So this is what we are hopefully gearing towards in the long term as well. But with this overall picture, reminder that this is really a multiple pathway, all the way from 1-year certificate programs for quick entry, 2-year associate degree programs, 4-year bachelor programs, all across, not just Ohio State. This is ASCENT wide, of course, don't forget. Given this region, and given that Intel is approximately located about where the eye is, okay, or in that circle, the one challenge I heard about Intel talking about, ideally they say that we know that our workforce come about an hour drive away. So they are going to be very interested about having a workforce that is within an hour drive. This is another, hopefully, advantage for us. So because Todd Grimes, our engineering technology program, has already entered a useful sort of relationship with, and a practical training relationship with Fairfield County Workforce Development Center. And we have a Lancaster campus, in case you did not know. And I'm now putting out all the related schools in this network, ASCENT network. I hope I didn't miss anyone. So approximate locations may not be accurate. But we put the Lancaster, Fairfield County is about the Workforce Development Center about 5 miles north of Lancaster. This is about where the star is. So it's really a nice kind of location. It's within 40 minutes drive to Intel. So Intel will consider this is the next county, essentially, next center to their center. We are hoping that that training center there for semiconductor related work will therefore have some benefit. Also we recognize here, not every college or every program can afford to put one. For various reasons, the Semiconductor Training Lab might be, in fact, if you think about it, in the state of Ohio, there is not even a 4-year or PhD granting institute that can do a chip manufacturing end-to-end. In fact, in the whole nation, there is only 4 or 5 sites, national foundations, science foundation supported nanocenters where, Berkeley, Stanford, Cornell, where they have an entire service, but they have staff and equipment donated and given to them with federal grants, of course. Given that, we have some research facilities that some of the larger universities, OSU, Cincinnati, our campus, and up north in Akron, etc. There are some facilities, but they are really research facilities, and they are not designed for dozens of undergraduates or technicians to come and do training type of work. Equipment is used for research. If it is down, everything, all research contracts can be delayed. So there's some need clearly for this type of facility. That's why we believe that putting an effort to a teaching lab will be useful. Recognizing those facts, and now, obviously, as I said, Ohio University and Hocking College have already relationship established and the programs established at the Fairfield County Workforce Development Center. I don't know if any other ASCENT members have made agreements with them. I just wasn't aware. I think there are some companies doing training there. I've seen one company listed as a partner for electrical training.
Claypool Workforce Center?
Yes, Claypool. Claypool. So they are, okay. And another good thing is they have applied, I think through the leadership of Ted's group last year, Todd's group, that we have secured some state funding to bring this type of tool. In fact, this is not just for semiconductor, other engineering technology group has other mechatronics technician and process control technician. Those technician programs have been awarded also some internal dollars to be put together this lab. And these are some of the programs Hocking College had, as well as Ohio University have currently. The certificate program, I don't think it is yet clickable, but it will incorporate semiconductor training program at some point, I believe, when you click there on their website. This is a capture of their website picture. And it looks like this. I think this is the current form. I don't think there's going to be change in the outside of the building. All the work is in the inside of the building. And if you look at the overall layout, this is where we are doing renovation, sort of remodeling and creating specialized spaces for one-year certificate programs and other programs that I mentioned. This is where the semiconductor training lab will be. Other spaces for, as I said, mechatronics and process, I believe these two. There are some teaching classrooms and there are some specialized, and this is kind of general atrium, students socialize and can form teams and etc. Now, there is, and this is up closer a little bit, so that's approximately where the vacuum lab will be, where we have a vacuum training course. This is where the semiconductor lab will be, where processing lab, so to speak. Actually, there's going to be a door. These two are connected in case needed. Otherwise, vacuum lab can operate on its own. Now, there is an interesting page here. Those of you who have smartphones or iPads, I would encourage scanning some of this if you can. Why? Because it has a 3D dimensional tour that you can have of the space. Unfortunately, semiconductor isn't being included in this one. Let me show you bigger ones. If you look around,
oh, here, got it.
So look around, there's a three-dimensional rendering of the space. I hope it works for everybody. Just look around. This presentation will be available, I believe. So you could...
yeah, we'll show the presentation.
Right. So again, as I said, this is only from spatial locations over here. Here's the classrooms that I can maybe put these three together, so in one go. So you could see this classroom one. So semiconductor one wasn't rendered at the time, I believe. So I don't have, I've seen the drawings, but basically it will aesthetically as well as practically nice looking environment that productively hopefully students will, so the students will be meeting together in the social area, mingling and then taking joint courses, because certificate programs, part of our 2-year associate programs running as well, so that they can actually do a couple of certificates over the 2 years period.
Question.
All right?
Question real quick. Do you have connections with the Fairfield Eastland Career Center here as well? Because the Fairfield Career Center is right across the street from.
Yes, they're a partner in
Are they
this
working?
center.
They are
I know
partners.
the Eastland side has all of their engineering, computer science, and everything.
Yeah.
And HVAC.
Yes.
Yes.
Well, I don't know how the two buildings will interact, but I always thought they are the same organization.
Yeah, Eastland
No.
Fairfield though the Career Center is a partner.
Are they?
That's what you're talking
Okay,
about.
yeah.
Yeah, yes.
Cool.
So exactly, that's, and I think there's an advantage. Even students over there can come for certificate training if they
Yes.
want.
Yeah, I didn't know that.
Okay, so this is how it will, there's some other codes here in case you want to see the entry point. I will take another minute in case you want to take another bite on the bottom. But again, I think this presentation will be available, Scott, so that you can, do this on your own time as long as you want, hopefully. So this is how it will hopefully look like. Now,
Yeah.
this is the approximate listing and approximate costing we figured into this operation that had 500K funding from the state level. Now, what I should point out, Vacuum Lab has its own 170 approximately K price tag, but it's all brand new equipment. And you'll see a little more details. Semiconductor Lab, on the other hand, my colleagues will tell me, will hopefully back me up, we could spend only that 500K only in one equipment if we wanted, depending on the size and the complexity of the equipment. So it was a challenge. What do? We decided to go, first of all, tabletop instruments if we can, and also used equipment where we can. And most times we can mildly use, we're not talking about historical pieces, relevant equipment, but there's an advantage going actually into smaller and used equipment. They tend to be both either purely analog or analog and digital together, so students can actually push buttons, create sequences, because what you don't want in a technician training, you stand in front of an instrument, only 3 buttons, and they don't know nothing except that instrument. That is not the training Intel is asking. Intel is asking ability to think about the fault an equipment develops, how you fix it, right? How you take it apart, how you put it together where needed, especially on the vacuum side. Because vacuum leaks develop, we know, we do work with the vacuum equipment, a perfectly working device in a year starts leaking and you have no idea, you need to take out, look into possibilities. It's a kind of detective work. This is kind of one scenario, of course there are others. Now, these prices are approximate because in the used market, I've been kind of looking around, but some instruments are still in the market, some are gone. Depends on the time. We'll have to maybe make do with some or spend money on others and less on others. Okay? Some of these instruments have big footprints, some of them are tabletop. And if you focus on this environment, so in this lab closely, this is from the later drawings. You could see the door will be right here between the two. This unfortunate lines are very thin, perhaps, but this L-shaped area, we have a service door and access door here. This is typically where we'll have some students can put their stuff here. We have some wet benches and lithography system here. Some of those vacuum instruments along the wall, and some of the clean benches across along the wall. What I would say is, there's enough space to get started, but I must also admit we have not really created a clean room as such, because that is way above our budget line. And also, remember, the construction is Fairfield County is actually doing the construction for. We're not spending money on the building. Now, can we live with it? Yes, we can, because we have a lot of vacuum instruments and tools where the processing takes in there. And then our objective is to show the process, not to get a working chip here, right? Obviously, this is what I designed, what I asked, and I think they honored that, to have a positive pressure room, so the air is always pushed out. So we're not getting dusty stuff coming into the room, okay? I think if we can manage the budget, we may put an air shower into the entry, a cabinet where students at least know how to gown and then go through an air shower, so they have a feel for how these things stand. Also, a big objective, we'll see, I'm working with some of the colleagues, and we have some other industrial links as well, to create a digital twin for this lab. So if you cannot bring students physically, at least you could practice some of these instruments as a digital twin with the AR, VR tools, so that maybe you can only bring a student maybe once a month. At least they will practice things, and when they come to the lab, they can actually take faster, be productive. That's the objective. So the digital twin idea, I think is a very useful one in that context, because not only they can practice on these tools, they can practice, like we saw yesterday, the Sol developed for Purdue University, an entire clean room twin for their big center. They can even be trained on those. So those tools, I think, will be quite useful. This is the layout, approximate layout I envisage for that center. Here's the 6 vacuum instruments that we, the vacuum training lab will lay out. These are some of the tools that we have. And some of the benches, there will be tabletop. I think we may end up having one more tabletop here, table or bench along the wall to put some of the tabletop equipment, but those are details I did not put in at the moment. What goes on just in case, the reason I'm showing this not to just to make PR here, the idea is, if anybody wants to replicate on their campus, we in an ASCENT group, we are happy to share our know-how and see if you want to indicate what are important. There are things for, of course, two-phase or 208 volt so high current supplies are needed. Some gas delivery, some exhausts are needed from vacuum instruments. So there's some infrastructure to be built in there, which costs, of course, and it has to be done right way, because you can't really, otherwise you end up with a lab, a lot of lines and a lot of pipes and a lot of stuff goes around, and it's a safety hazard environment for teaching. You want everything nicely tucked in a way, and clean walls, and hopefully nothing hanging around for students to trip and cause accidents, etc. The vacuum lab, in fact, I probably mishandled the order of the one second. Oh, I think I missed that. Never mind. So what I think the lab looks like this. Lab looks like this. 6 stations are where students are working on first level vacuum pumps, the rough pumps or rotary pumps. I believe the central station has the high turbo pump central chamber, which is a second level higher quality pump a lot of the vacuum instruments today use. And these 2 drawings I will overlap again. This is how the system will look like. And Eric has sort of worked with the other colleges who are using similar type of tools, I believe, around the state, because Intel asked for a unified vacuum training. And I believe some of you guys are also getting the similar set of equipment on your local campuses, which is very good. So we can actually, if something down in any one institution, you could still do training in the other if things are, sometimes tight and you can't fix the equipment in short order. All right. With that, some of the examples of the tools that are including, I don't know if this is the correct one, or maybe an extra slide on like this. So we have clean benches, okay? Clean benches, this is not exact, the one they sent me has only drawing, not picture, and couldn't find their picture, but it's essentially approximately like this. The one we have is going to be 8 or 6 feet wide. We will have a tabletop, dry, for the dry processing. For wet benches, it's going to have a sink and a hose and a couple of nitrogen guns and things like that so students need to handle wafers, break them, clean them, etc. So those type of work environments. And this is actually more clean environment. They will have filters, so they will hopefully work in a better clean environment that way. Mask aligner, you need to do lithography, you need to do projection, lithography, contact. We use mask and sample in contact, just like our demo. This is one of the used equipment, and there are several of them around, so I'm hopefully getting one like this. This is the light source. You put the sample in the sample holder. Mask is held, I believe, in this fixture, and then they are getting in contact. And this swings to the right when you want to do alignment. You have 2 sets of microscope pieces, so to speak, so you can study across the wafer. If you are doing an entire wafer, make sure you can align one pattern to another pattern, because one mask will align to the existing patterns on the wafer. So you need to do alignment across a large area. That's why you need that 2 illumination, 2 microscopy heads. And then all the necessary things will be housed in this one table system. This is a rapid thermal annealing system we are aiming at. This is useful because a lot of the modern processing in semiconductor, you don't subject wafers to extended periods of time on high temperatures. This thing has a lamp heater, halogen infrared heaters, that I believe they turn on. You could turn it on maybe 10, 20, 30 seconds. Quickly temperature rises at the surface of the wafer, close to 800, 900, depends on how you set it up to 1000 degree, I believe. And one wafer at a time. These are not, and you can see this a quartz table. You put the wafer for clean processing. And if you feed oxygen, you could do oxidation. If you could feed nitrogen, you could only cause maybe some thin forms of silicon nitride on the surface. But the idea is to show lamp, and this is basically not a vacuum system, but it is basically one important processing step modern industry uses. Plasma system. We are aiming at a tabletop plasma system like this. Open the door, put the sample, all the control and gas is in the behind the cabinet. Fairly simple system. And then this is basically computer control. There's no button on this one except all digital buttons. But I'm also looking at alternatives. There are some alternatives. If you're not buying this one, the only reason will be we'll buy something where students can do both digital control and analog handling. Or open valve, close valve, start the plasma, stop the plasma. So they gain a little more hands-on skills that way. Evaporators, you want to evaporate metals or sometimes even insulators. This is a tabletop sputter system. It uses plasma generated in this, and then you incorporate one or two. In this case, it is capable of 2 different metals. You could do at one or in succession. The idea is plasma of argon, typically big atoms, they beat down on the target under the plasma condition. The targets essentially like you get chips of tiny flakes of that atoms condensate on the wafer, which may be slightly, may or may not be heated. So this does the one type of metal deposition. This is a thermal evaporator. This one system is very nice. It has actually one source currently, but it can be modified so you can actually evaporate multiple metals if you like. Well, again, these are some of the used instruments on the market. That the left one is brand new. That's affordable. We may get that one brand new. But these are the type of instruments we are talking about. Now, the overall message, hopefully, our objective is the construction is going on, right, Scott? That's what I know. Within the next 6 months, by the end of the year, we complete the purchasing of most of these and installation of most major pieces. And hopefully we can do a first run in the spring to 2025. And that we are also developing the curriculum that goes with it, of course. And we are, as ASCENT members, you're welcome to blend into that curriculum. We can share it, or we can also incorporate, if you want to drive your students up once a week for a specific class experience, that can be probably arranged.
Any one of these instruments can break down, right, and needs to be maintained and repaired. So how is that going to be handled?
Good. So we are currently, we advertise a visiting position that basically somebody who work in this environment who can handle instruments for the next 2 years. We believe we can cover it. And the steady state, to be honest with you, well, it's a good question. In the long term, I think the registration will be key. As long as we have student numbers, that can be justified, and we believe we can find enough state funding as well as local funding to support that operation. In the worst case scenario, I believe most trained graduate students that can handle equipment and they put together their equipment. We have graduate students who build equipment actually, especially in the physics department. They are even better at that.
You live right up in Columbus, right?
Yeah, we will be on the. Okay, I will be obviously one resource to help out ironing the rough bits, but hopefully. I think the key number is key. If we cannot achieve a steady state high number, one can even question the entire operation. Why you would want to keep a semiconductor training lab when you don't have the number of students that you have. So I think the two together, if Intel and then other activities create that expected rush of students, that should solve itself. Also, you know, there's going to be an income stream from the number of students as well. Any other question?
What, just maybe I missed it somewhere, but which program is this lab?
1 year certificate. This is designed currently for 1 year and 2 years
It's a program.
This is based on the curriculum that Intel has built at the OACC. This, I think, is their
Yes.
semiconductor.
So this is intro to semi what I'm.
Right,
kind of want.
yes.
That is
Same one that
with-
you guys
with-
have.
We might modify it a little bit, but it's based on.
Exactly.
Chip, to answer your question, I think your question is tied to what certificate or what degree this is tied to. This is out of our regional campus. They have an engineering technology degree, associate degree. And so the 1 year certificates will stack the mechatronics and the robotics 1 year certificates that exist already, plus the 1 year semiconductor. They'll all stack and a couple of electives you can get an associate degree. So you get a 1 year certificate and bail and work, and it's transcriptable, so it's on your transcript. Come back, you know, at your pace, get a second certificate, 2 classes, you get an associate's degree. The engineering technology program reports to the engineering technology and management program here in the college. So that's Todd's program, Todd Meyer's program. And in theory, you know, for those students who are interested, can move to the 4 year degree program here. So you can do a 2+2 program here.
But this is basically taking what OACC
Yeah.
developed
Yes.
as a 3-hour
Correct.
lecture-based class and providing the lab-based component to it.
This is a 5-course sequence.
Okay.
Yeah, and it's 5, and what I was gonna add was that, you know, the electronics automation and then this certificate, all 3 of those 1 year certificates, they do carry a common set of courses between them, which is like the digital circuits, I believe, and then there's one other. So the nice thing about that is, if you take 1 certificate, you've already got 2 classes, and the next certificate, so you
Right.
kind of, and then if you get, and people are talking, then if you get a couple of those extra electives, you can get an associate's degree, you know, so it does, the nice thing is.
It's
there's
a stackable.
Yeah,
Yeah.
it's stackable, there's a path, and then what Scott was saying is, it can even carry forward into the 4 year degree
Yeah.
in the ETM department.
So can our partner colleges send the students there for hands-on training?
Yeah, that's what
Yeah.
I was telling
So,
over.
are you adopting the semi 101 from OACC?
Yes.
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 But, I mean, this is so much more than what's in that.
Yeah, because they literally told us we didn't need any of that.
Yeah,
Intel.
But Intel will look at whose students are getting most hands-on experience, and I'm
Ah,
sure.
you're looking at okay.
But this is double what
Yeah, it's-
we're taking from them.
Well, indeed,
Well, yeah.
if you look at their lecture materials, Semiconductor 101, they have all these instruments introduced.
Right.
Most of them.
Right, but not hands-on.
I don't know what the expectation. Some colleges do. I hear like
I don't, the semiconductor class is much different than the vacuum class, because vacuum class is
Right.
like, here you are,
That is
here it is,
yeah.
here you go.
Yeah.
They don't really have anything for the semiconductor class. We saw this as an opportunity for us to sort of take some of the knowledge we have here and see if we can do something.
Yeah.
We're trying, I mean, I hope
This
it
is
works.
great,
Is it-
it adds the lab-based component, but it's actually another class.
And one thing that's fantastic about this is it builds on that vacuum class, because all of that piece, both those pieces of equipment
Yeah.
rely on vacuum systems.
Right.
So you can see how that vacuum system that you trained on is integrated in actual equipment and how it actually operates and where the faults happen in an actual process, so.
In fact, we haven't completely instituted, but one idea is we do a small capstone-like project
Right.
where student takes vacuum training, student takes the semiconductor class, some of the learning,
Yeah.
and we tell them go and do
Right.
deposit 100 nanometer of gold on 10 nanometer of oxide. Something very simple like that, where they they do the processing of 2 steps together, and they show that they can handle the vacuum systems.
So, question with that, so is the engineering and technology program at OUL, that is the prerequisite for this program, along with other articulation?
No.
Not a prerequisite.
You could just take this alone as a certificate,
Oh,
semiconductor certificate.
so
One
what
more.
prerequisite would you need for that?
What Todd would say is a high school degree, that's it.
Yeah,
No prerequisite.
This is high school.
they literally told me a high school degree.
And you could do this.
Plus this.
program?
However, as
Plus
Dr.
semi 101.
Well, the three classes.
Yeah, one of them is the 101. But at the same time, as Dr. Steiner was explaining, if a student takes this, they will soon discover, oh, I take 2 or 3 more courses, I get also
Yeah.
process control certificate.
right.
Oh, and I do 2 more. This will be, I think, a nice, because they are not committing to a 2-year, 2.5-year, 20 credit something. It's more manageable chunks. That's the idea.
That's sort of what I did with when I did my certificates. With their gen eds, same idea, but we'll get you hooked and then get your gen eds and we'll get you.
Yeah. So basically, technology buffet, you're sampling the way you like.
Stuff you gotta do.
Yeah.
All right. Any other question, comments?
Is there any math or reading level or composition?
Very good question. There is inevitably some more difficult science subjects here lurking in the background. Our idea is at the 1-year certificate level, our purpose is never show equations or math, but explain the purpose, intent, the end result, and what type of technical skills will we need to maintain these devices. They don't have to know the process, how to design a process, except operating the instrument. That's.
I would just say that it's incumbent on us, because we've said the prerequisite is a high school degree, that's what you need.
Yeah.
And so that may answer the question in the sense that the curricula should be designed that we can get across how to operate these tools without having to add on to that. That's the hope.
I think the key is the vacuum course. When you establish you're working in a specialized environment, there are sequences of things to do. You can't just open a window, open a valve, press a button, and random. And then basically, in fact, this is what Intel wants. Intel wants people who can follow a protocol very strictly as a team, and also have some question in mind of if this makes sense when they do an action, when they take a reaction. Is that meaningful?
Okay. So it's more operator level? Not
Yeah, of course. Of course. At this level, for this center, the 1-year certificate program is all about operator and technician level. However, if this is successful, we're getting all the numbers. We have 2-year programs. Those students may be subjected maybe an additional course for a little more higher detail if the need arises. These are all future things that we need to consider. All right. Thank you very much for everybody.